want to treat the relationship between angular acceleration and the linear acceleration. So let's derive the equation. Angular acceleration is the rate of change of angular velocity, just like linear acceleration is the rate of change of velocity. Okay, now, and what is the formula of angular acceleration? Our angular acceleration is alpha is equals to W1 minus W0 all over time. Okay, now this is the formula for angular acceleration. That is final angular velocity minus initial angular velocity all over the time taken. Okay, just like linear acceleration is v minus u over t. That is final velocity minus initial velocity all over time taken, right? And the unit of this angular acceleration is radian per second square. In the previous video, I have treated between the relationship of linear velocity and angular velocity, which the formula is v is equals to angular velocity times r. Linear velocity is equals to angular velocity times the radius of the circle. Okay, now in making angular velocity subject of formula, we now have v over r. We now have v over r. It is this one now we are going to use to exchange this. We exchange this thing with this. Since this is equal to this, we are going to exchange it with this, right? Now let's exchange it. We will now have angular acceleration equals to this one will now be this v 1 over r minus v 0 over r. Okay, all over the t. Remember, I just exchange this. Since this is equal to this, and I pick it, exchange it here. That's what I have done, right? So don't be confused. We now have alpha equals to factorizing the radius of the circle. Factorizing the radius of the circle, now have this in bracket v1 minus v0 close all over t, which is equals to this one. We change this thing to divide by t. Remember, this divide by t. Okay, changing this to multiplication sign, right? We now have equals to r bracket v1 minus v0 close. Change this to multiplication sign. It will now be 1 all over t. When you change this to multiplication sign, it will now toss up sign. You now have 1 all over t. Do you understand? Now when we multiply it, we'll now have in bracket times times in bracket v1 minus v0 all over t. When you multiply out, you now have this. And remember that our linear acceleration is equals to v minus u all over t. And you know just that we just use letters to represent it. V represent our final velocity, U represent our initial velocity. If I like, I will use another letter to represent that, which I can use V again. This one will be V1, this one will be V0, right? So that the V1 will be final velocity and the V0 will be initial velocity. And since we have this, look at it here. We can now remove this completely and insert our sign A, which will be represented as linear acceleration. Now let us take this thing out and replace it with this. Since this is equals to this, okay, we now have alpha equals to times A, because our A is equals to this, which is finally we have A over R. That is alpha equals to A over R, making a subject of formula. Now have alpha multiplied by R. So it will now be linear acceleration equals to angular acceleration multiplied by the radius of the circle. So this is the relationship between linear acceleration and the angular acceleration. This is that. So the next thing now is to have question concerning that, which will come in next video. Thank you for watching. Please subscribe. Okay, thank you so much.